right, we're going to go ahead and play fair or unfair to practice our theoretical and experimental probability. You should have already taken notes on 10-7, theoretical and experimental probability. And this is going to extend the notes and help you get more of an understanding of the difference between theoretical and experimental probability. You can play with another person or you can play against yourself if you can't find someone else to play against. You're going to need the following materials. A printed copy of the fair or unfair handout. Now that's not necessary if you can't print. Everything you need, you can view in the video. So if you can't print this handout out, you can just use binder paper or put the tables and things in your composition book. You'll need 2 different colored pencils, markers, pens, 1 color for player A and 1 color for player B. And you're going to need 2 dice and 2 coins. Please pause the video now as you gather your materials. All right, game 1, called Match and Mismatch Game. In this game, you're going to use 2 coins. It doesn't matter what coins they are as long as they have a head or a tail, which is all coins. Player A, you're going to get a point if there are 2 heads or 2 tails. Player B, you get a point if there is 1 head and 1 tail. It does not matter who tosses the coin. If player B tosses the coin and it lands on 2 heads and 2 tails, player A, you still get a point. I'm going to erase those points that are there. All right, so let's say player A tosses the 2 coins and it lands on 1 head and 1 tail. Player B, we're going to put a little tally mark there. Let's say now player B tosses the coins and it lands on 2 heads and 2 tails. Player A, you get a point, and so on. And that's how the game will go until the first player who gets up to 7 points, right? That's going to be the winner. Before we start to play the game, let's look at whether this is a fair or an unfair game. Based on how each player can earn points, make a prediction. Do you think this game is fair to both players? Do they both have an equal chance of winning? Or is it unfair? Does one player have a better chance mathematically of winning than the other? All right, let's pause the video while you play, and I'm going to go ahead and play against my husband. Okay, how'd you do? This is how it ended up between myself, which is I'm player A, and my husband, he is player B. I was able to get 2 heads or 2 tails 7 times, so I'm the winner, and my husband was able to get 1 head and 1 tail 6 times. It looks to me, we've got a little question down here, was the game fair or unfair? It looks to me, mathematically, because of the way my experiment came out, that this was a fair game because we both got very close number of winning rounds. But over here, I'm going to be blue, okay, player A. I got 7 wins out of the total of 13 times that we were given points here. 7 out of 13. So 54% of the time, I was the winner. And player B, red, that's my husband. His name's Rod, so red for Rod. He got 6 wins out of the 13 total times that we tossed the coins. So 46% of the time, he won. Still really close, 54% and 46%. It still looks like to me experimentally that the game was fair. But now let's go over here and look at theoretically. Okay, now we're going to theoretically show what the math says should have happened. Event 1 and event 2. Those are just the 2 coins that we tossed. So event 1 is just one of the coins. Okay, I'm going to call it coin 1. And event 2 is other coin. Okay, I'm going to call that coin 2. So on coin 1, right here, these are just the possible outcomes, okay? I could have got a heads or a tail. Same thing for coin 2. These are my outcomes. I could have tossed it and got either a heads or a tail. So when you're setting up a table like this, know that these are the possible outcomes. Okay? Those are the possible outcomes that each event gives me. And then when I'm finishing my table, I see that the sample space, okay, inside this right here, I'm going to highlight that with green. Right inside here, this is my sample space, okay? These are all the possible outcomes I could get. I could toss the coins and I could get a heads and a heads. I could toss the coins and I could get a heads and a tails. I could toss the coins and get a tails and a head. And I could toss the coins and get a tails and a tails. Okay? So that is my sample space. I'm going to fix this H here so it looks more like an H. That was my heads. So let's look how mathematically this game was for each player. 2 heads and 2 tails were the possible ways for player A to win. 2 heads, and I'm going to circle those with blue because player A was blue. So 2 heads and 2 tails. So player A had a 50% chance, okay? Player A had a 50% chance of winning. And player B, either a heads or a tails or a tails or a heads, also had a 50% chance of winning. So mathematically, this game was fair, okay? This game was fair. It says if the game was unfair, what could you do to make it fair? Well, we know that both of these players had an equal chance of winning, so this was a fair game. All right, ready for the next game? Game 2. For this game, you will need 1 coin and 1 die. And every time that you play, you'll flip the coin and die together. Player A, you will get a point if you get heads and a number greater than or equal to 2. Player B, you will get a point if you get tails and a number less than or equal to 4. And again, the first player to get 7 points wins. Remember before you start your game to circle what your guess is. Do you think mathematically, theoretically, this game is fair to both players? Or do you think it's unfair and one player has a better chance of winning? Go ahead and make your guess now. Pause the video, play the game, and we'll see how it turns out. All right. This is what happened with my husband and I. Again, I won. I got 7 wins, and my husband only got 4 wins. In this case, I'm only going to count the number of times that we got each of our desired outcomes. Okay, so 11. I've got 11 total marks on my board here. According to my experimental probability, it looks like that this is not very fair. I'm going to say this is unfair because I won 7 times and my husband only won 4 times. I almost won twice as many times as he did. So it looks like this experimentally is unfair. And if you go look at the percents over here, I won 7 out of the 11 times we were able to put a point on the board. That's 64% of the time. My husband Rod, he won 4 out of the 11 times. That means 36% of the times we were able to put points on the board, he was the winner. Well, let's check this out and see mathematically if this was, or theoretically, if this is a fair game. All right, event one, you can see I only have two outcomes here, so that has to be my coin. Okay, and so possible outcomes are heads and tails. Event two would be my die, and possible outcomes on a die are 1, 2, 3, 4, 5, and 6. Okay, all right, I'm going to make my pen a little thinner so it fits in these little tiny boxes. Okay, so we'll finish our table. This is a 1 and a heads. Oops, trying to make my pen thinner. This is a 1 and a tails. This is a 2 heads, 2 tails, 3 heads, 3 tails, 4 heads, 4 tails, 5 heads, 5 tails, 6 heads, and 6 tails. Now remember that this right here, okay, this is my sample space. This is my sample space. There were 2, 4, 6, 8, 10, 12 different outcomes in my sample space. I'm going to go off topic here just for a minute. Let's look. On the coin, there are 2 possible outcomes. And on the die, there are 6 possible outcomes. 6 times 2 is 12. So I have 12 possible outcomes in my sample space. That's how we know how many total outcomes we'll be looking at. Okay, I'm going to take my blue and I'm going to circle all of the outcomes that give me a heads and a number greater than or equal to 2. Heads greater than or equal to 2. That's 1, 2, 3, 4, 5 out of 12. So player A had a 5 out of 12. I'm going to see what percent that is. 5 divided by 12. So player A had a 42% chance. Player B, let's circle that in red, had to get a tails and a number less than or equal to 4. So that's 1, 2, 3, 4. Aha. Player B only had a 4 out of the 12. Player B only had a 33% chance of winning. So this game was unfair. This game was unfair. Player B had less of a chance of winning, and you can see experimentally player B did not win. And player A had more of a chance of winning, not a lot more. And really, I think the percents kind of play out very well with what happened in the game between my husband and I. The next question says, if the game was unfair, what could you do to make it fair? Think about that. If we had 1, 2, 3, 4, 5 chances here and only 1, 2, 3, 4 chances here, we could have said player B could get a point if they had tails and a number less than or equal to 5, and that would make our game fair. Ready for another game? Okay, in this game, you're going to need the 2 die, the 2 number cubes. Player A, you get a point if the sum is even. Player B, you get a point if the sum is odd. This time, the player with the most points after 15 rolls wins. All right? 15 rolls, and we'll see who wins. Don't forget, make a guess. Do you think this game is fair or unfair? All right, pause the video now and play your game. This is how it ended up between my husband and I. This time he was the winner. He won 10 out of the 15 times, and I only won 5 out of the 15 times. So he won 67% of the time, and I only won 33% of the time. Well, experimentally, this game looks very unfair. My husband won 10 times. He won double the amount that I was able to win. Let's look at the theoretical probability and see if this game, in fact, was unfair. All right, event 1 is die 1. Event 2 is die 2. And each die has an outcome of 1, a 2, a 3, a 4, a 5, and a 6. 1, 2, 3, 4, 5, and 6. Okay, now it's about the sum. So I'm going to calculate the sum in each box. 1 plus 1 is 2, 2 plus 1 is 3, and so on. Okay? You start to see a pattern here. 2 plus 2 is 4, and then you can just keep going, right? No. 1 plus 1, this is 4. Ah, I think I made a mistake here. Hang on. Should have started with 3. I got carried away. Okay, so 1 plus 2 is 3. Here we go. 4, 5, 6, 7, and 8. Okay, and this is the column that I thought I was in. 1 plus 3 is 4, and then we go down. This is 5. This is 6. And 8, 9, 10, 11, and 12. Okay, now, sample space. On each die, there are 6 possible outcomes. So that means 6 times 6, there will be 36 outcomes in my sample space. So this is my sample space. These are all the possible sums you can get by rolling the 2 die. Remember, that is your sample space right there. Okay, I'm going to take my my blue, and circle how many possible ways that player A, which is an even sum, gets to win. Okay, so even, I can actually just go sideways, right? I like that pattern. Okay, so now I can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay, player A. 18 out of 36, well, that's 50%. That means what's left for player B, odd numbers, is another 50%. So theoretically, this game was fair. Each player had a 50% chance of winning. But if you look back at the experimental probability, it did not play out like the theoretical probabilities say that it should. So experimental and theoretical don't always even come close. All right, last one. You're going to need, again, the 2 die. And this time, player A, you get a point if the product, remember the product, that is when you multiply 2 numbers, is even. Player B, you get a point if the product is odd. Okay? Make your guess. Is the game fair or unfair? Pause the video and play the game. So I did not play this last game with my hubby. He had to leave to go do a job. But let's theoretically figure out if this game is fair or unfair. So again, I have my two events, the things that we used. That's die 1. There are 6 outcomes on die 1. Second event, second thing we use to play the game is die 2. Okay, and again, that's 6 possible outcomes. So we know in our sample space, we're going to have 36 outcomes. I'm just listing the outcome for each item that we used, just like we did before. Now this time we're going to look at the product. 1 times 1 is 1, 2 times 1 is 2, 3 times 1 is 3, 4, 5, 6. 1 times 2 is 2, 2 times 2 is 4, 6, 8, and 12, right? This is 3, 3 times 2 is 6, 9, 12, 15, and 18. 4, 8, 12, 16, 20, and 24. These are all the products in my sample space. 5, 10, 15, 20, 25, 30, and 6, 12, 18, 24, 30, and 36. These are all of my products. Okay? Again, 6 times 6, 36 total outcomes. Okay, this is my sample space that I have encased in green. All right, player A, you would have been blue. So player A, if the product is even, so I'm going to circle all the even, 2, 4, 6, 8, 10, 12, 2, 4, 6, 6, 12, 18, 4, 8, 12, 16, 20, 24, 10, 20, 30, 6, 12, 18, 24, 30, and 36. Let's see, did I miss any? All right, so we want to know theoretically if this game was fair or unfair. Well, out of the 36, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. 27 out of the 36 total outcomes. 27 divided by 36. 75% was player A's chance. That means player B, you only had a 25% chance of winning. Was this game fair or unfair? Definitely unfair. It's definitely a game that was set up for player A to win. When you played the game, did player A get 75% or close to that total wins? All right. I hope this helps, and I will be posting more videos next week. Monday is a partner quiz. You don't have to have a partner for the quiz, but it would be ideal if you could get on the phone with somebody and complete the partner quiz together, but you each need your own copy. All right, have a great day.